and we can see your screen. You have 8 minutes, please.
Great. Hello, everyone. This is Jiang Taogong from Tsinghua University. Today, I'll on behalf of my co-authors to present our work entitled with TeleAware Robot, Design Awareness-augmented Telepresence Robot for Remote Collaborative Locomotion. Remote collaboration has become increasingly common in our daily life, particularly in scenarios that participants are moving with physical space, such as during conference attendance or joint shopping experience. When people work together in the same location, they naturally develop strong environmental and social awareness through unconscious movement and interaction. Engaging in activity like guiding, navigation, and sharing points of interest that create a natural shared experience. While Telepresence robots offer significant benefits for remote collaboration, they face notable challenge in locomotion tasks due to the limited spiritual awareness and difficulty in maintaining natural social interactions. This research aimed to enhance social and environmental awareness in telepresence robots by studying how pairs naturally navigated exhibition together and gain insight into robot design. We conducted an observational study of pairs within exhibition together to understanding awareness needs in collaborative locomotion. Our research included 4 diverse exhibition settings within different visitor dentists, from spas to clouded environments and rural types. We conduct semantically video coding focused on user-partner environment interaction framework. We developed a comprehensive codebook to analyze their interaction behaviors. First, we found that visual perception remains over 80% channel environment understanding and navigation, while the telepresence users experience limited the environment visibility due to the restricted camera perspectives. This leads our first design goal, enhancing environmental visibility for remote users to improve their spiritual awareness in telepresence robot. Thus, we developed the TeleAware robot with a comprehensive visual system combining a multi-camera system, both the robot body and the surrounding environment. Besides, we observed that the participants regularly check their partners at an average frequency of 1.6 times per minute to maintain social awareness, which lead to our second design goal, enhancing remote users' ability to perceive the locomotion and status of the local users in telepresence robot. Our system calculates the relative distance and direction of between local user and the telepresence robot, displaying this on the remote user's screen. This solution enables continuous awareness of local partners' position and status. Moreover, we also found that 9 out of 16 observed paired engaging with real forms of physical contact interaction for social awareness, which lead to our third design goals, enhancing the embedded interaction capability between local and remote user in telepresence robot design. Thus, we install the 4 sensors on both sides of the robot display screen to act as shoulders, simulating how a person would react when tapping their shoulders. This design creates a more immediate and natural physical touch response into telepresence experience. What's more, we found that the joint environment references through gaze following and the gesture indicator occurring at frequencies of 1.5 and 2.5 per minute, respectively, which inform our the fourth design goals, supporting equal capacity for both local and remote users in joint reference environment information to improve situation awareness and enable natural leadership transitions. So we develop a two-way reference system for mature understanding. For remote users, we implemented a human pose exclamation algorithm that recognize local users' point gesture and display the visual touch line vectors on the remote user's screen. For local users, we installed a projector on the robots that allow remote user to indicate directions and objects by projecting the trajectories onto the floor. To evaluate the efficiency of our design, we conduct 2x2 mixed experiment to compare the TeleAware robot against a standard Telepresence robot, with participants alternately between leader and the follower roles in excavation-like environment with display board. Our evaluation of the TeleAware robots revealed significant improvement in user experience, with the participants reporting lower cognitive demand and less frustrations compared to the standard one. Furthermore, the analysis of physical promising showed that users maintain closer collaborative distance with the Telepresence robot compared to the standard one, for indicating more natural and comfortable interaction patterns. Analysis of the social presence skill revealed that TeleAware robot significantly enhanced the mature awareness across all dimensions compared to the standard condition. To our surprise, our analysis of leadership role revealed that the remote user operating the Telepresence robot can efficiently lead through alternative strategies, while the local user has the natural advantage as leaders. The remote user completed the task even more faster. The TeleAware system significantly enhanced the remote leader's experience by reducing isolations, with user reporting stronger presence awareness compared to the standard one, enable more coordinated collaborative locomotion. This concludes our presentation of our work. Thank you for your attention. We welcome for any questions.
Thank you very much. Do we have questions? We have one question.
I'm specifically curious about the tap. So when the local user tapped the remote user, did you inform the remote user of the tap and how? And if you didn't, did the remote user reported or said something about the experience of the robot moving without them commanding it to move, so they didn't expect the movement, basically?
That's a good question. I think the shoulder tapping feature is very interesting because local user has can operate the Telepresence robot that makes the remote user with a very quick awareness that local users is calling them, and the UI on the remote user screen also will have alert that local user is calling them. So I think it is a very fast and with some force interaction on this interaction way.